In preview activity 1.6, we're given the graph of a function of a car's distance measured in thousands of feet. So distance is along the y-axis as a function of time measured in minutes. So time is in minutes. This is in distances and in thousands of feet. Now, part A asks us to describe the behavior of the car over some of the time intervals and discuss what's happening. So first off, we notice that the car is always driving away. So let's look at a few of the intervals. For instance, from 0 to 1. From 0 to 1, we see that the distance is increasing, and we see that it's concave up, so it's increasing at an increasing rate. So it starts off at rest, and it's speeding up, it's accelerating. From 1 to 2, we see that the distance is still increasing, but it's concave down, so it's slowing down, but it is still moving forward, so our distance is still increasing, our position is still increasing. Look at from 2 to 3. We have no change in distance. Right? So we have no rate of change, so the car is stopped. Then it starts up again, speeds up, gets to a maximum speed, and then it slows down and comes to another stop. Now it's stopped for 2 minutes, excuse me. And then it starts up again, it accelerates, hits a maximum speed, decelerates, but is still moving forward, so our position is still increasing, then it stops again. So we kind of see that pattern continued. Now, on the entire interval 0 to 12, we do see that we have an increasing rate of change, and we can find the average rate of change on that from 0 to 12. Looks like at 12 minutes it's about 16,000 feet, so we'll convert at the end. And at 0 minutes it's at 0 feet, and this is during a time interval of 12 to 0 seconds. So our average rate of change is 16 over 12, or 4/3. And then remember, this is in thousands of feet per minute. So we have about 1,333 roughly feet per minute. I went ahead and rounded that off. So that's our average rate of change. So that's the constant speed we'd have to be going to make the same trip to cover 1,600 feet in 12 minutes. Notice that it's positive because between 0 and 12 minutes our position is increasing. And as we look at our graph, our position was always increasing, or at 0, we never saw any place where it dipped back down or where it was decreasing. That'll be interesting as we start to draw a graph of the derivative.